Great, thank you. And thanks to all the colleagues. Good morning to Padua. I'm sorry I could not be there in person, but at least thanks for allowing me to join this program online. So what I'm going to do in next 10 minutes is to give you an overview of Indian lunar program. As you know that India started its lunar program with the launch of the Chandrayaan-1 mission in 2008. And incidentally, it also had a very exhaustive collaboration with European colleagues. We had 4 experiments where European colleagues participated in it. 2 was European-Indian collaboration, the Chandrayaan-1 X spectrometer and the SARA. And we had a fully European collaboration on SAR-2 and add-on. In addition to that, of course, we had US participation in there with M3. There is a moon mineral mapper from JPL and Brown University, as well as MINISAR from APL. And there were 5 experiments from India. So this was essentially meant to do chemical, mineralogical, petrological mapping of the whole moon in the visible, near infrared, and low and high energy X-rays. And of course, to look at in situ measurements. In 2019, precisely to be on 22nd of July, we had the launch of the Chandrayaan-2, which carried 8 experiments on board on the orbiter. And there were other experiments on the lander and the rover. We all know what happened to the landing. But these experiments on the orbiter, 8 of them are working very well and providing excellent quality of data. And I will talk a little bit about that if time permits. We are now having the Chandrayaan-3 mission, which is going to go next month. And this is going to be a lander and rover mission. And I will talk a little bit about that. So talking into more details about the Chandrayaan-1 mission, which of course was truly international, as I just mentioned, carrying 11 experiments on board. And I was directly involved with the experiment called SARA, which stands for Sub-KV Atom Reflecting Analyzer, which also had 2 sensors, SWIM and CNR. And on the top, you are seeing the Moon Impact Probe, which was a standalone satellite of its own, which actually, after we reached 100 kilometers circumpolar orbit, it was released to land into the south pole of the moon, which actually made MIP the first man-made object from India to land onto lunar surface. SARA, the Chandrayaan-1 has brought out excellent science results. And the most important, of course, you know very well, is the discovery of water on the moon, not only on the moon, above the moon and below the moon surface also. In addition, of course, we validated the lunar magma hypothesis. We discovered mini magnetosphere on the moon. And to say that moon is geologically active because there has been volcanic activity happening in the moon in the very recent past, going down to almost 10 million years. And many of these results actually came as a cover page of various journals. So 2 of them are highlighted over here. And since I was just involved with the SARA experiment, I will just give you a glimpse of that in terms of what we knew of how solar wind interaction takes place with the moon, because moon goes around the sun, around the Earth, taking about 27.5 days. So about 7 to 8 days, it is inside the Earth's magnetotail and magnetosphere, but rest of time it is outside. And this was the kind of picture which we had before the Chandrayaan-1 of how the solar wind, which is a flow of plasma from the sun coming and interacting with the moon surface. But this whole simple picture has been translated into this complex picture right now, where we know that a very significant amount of physics is going on onto the lunar surface just because of the interaction of the solar wind with the lunar surface. I will not go into detail of this. You can read too many papers which has come out from this. One important one, which I'm just highlighting, which actually became the ESA press release on October 16th of 2009, which suggests that hydrogen offers a new way to study the moon, where we actually see a very large amount of energetic neutral hydrogen atoms coming out from the lunar surface simply because of the solar wind having a charge exchange at the lunar surface, and about 20% of that coming out from the lunar surface. And this is talking about the GRL cover page, which is the discovery of the mini magnetosphere on the moon from the ENA measurements. Chandrayaan-2 is a much more complex and complicated mission than Chandrayaan-1 because it not only had the orbiter like in Chandrayaan-1, but it also had a Vikram lander and a Pragyan rover. And I'm not going to go into details of what happened with the landings, but the orbiter, which was sitting over the composite, which you see over here, had been doing very well. We had a launch on 22nd of July, as I was just mentioning, and 8 experiments on board on this are working very well, providing excellent quality of data. I will just quickly glance through. I hope I have still 5 minutes left. So OHRC is one of the very high resolution camera on board, providing resolution of 25 centimeters at the lunar surface, particularly in the polar regions where we have less amount of data available. And this is now being used for the Chandrayaan-3 landing site scouting as well. We have got excellent data about argon-40 distribution from CHASE-2 experiment, and you're seeing on the top how they are quite patchy. We have got much better coverage of lunar hydration, particularly talking about the distribution of water and OH molecules, and excellent information about the distribution of elements on the lunar surface, particularly the magnesium, aluminum, silicon, calcium, iron, titanium, but also about the sodium and distribution of sodium across the moon. We had an experiment called a solar X-ray monitor, which is, of course, one of the best instruments currently operating in space, providing the data on the X-rays from the sun, which is essentially required for doing fluorescence on the lunar surface. And this information is coming every 1 second for energy range of 1 to 15 kV. And excellent science has come out, even talking about the discovery of microflares on the surface of the sun, even during the deepest minima of the last centuries. And the dual frequency radio science experiment talking about a very large amount of ionospheric presence in the wake, or I should say across the terminators, which has been discovered by the plasma experiment on the Chandrayaan-2 using a dual frequency radio science experiment. Right now, we are working over Chandrayaan-3 mission, which is going to be a purely lander and rover mission, duplicating more or less what we did in the Chandrayaan-2, but of course with much greater and enhanced technological capabilities. So we had a lander, which is named as Vikram, and the rover, which is going to be coming out after we did the landing, called Pragyan. And this is going to go next month, mid of next month, that is July, where we are going to go to the moon to 100-kilometer circular polar orbit after the launch and all those maneuvers, come down to 100 by 30 kilometer, and then descend into the polar regions. We have 4 experiments on the lander, the thermal probe, the Langmuir probe, the seismometer, as well as a lunar retroreflector from NASA. And we have 2 experiments on the rover, alpha particle X-ray spectrometer and laser-induced breakdown spectroscopy. And so we have experiments on the lander as well as on the rover, and they will provide us a lot of in situ measurements in the high latitude regions. So this is just a cartoon which I just copied today for these presentations, talking about the whole mission. About 4 tons of kg of the total mass of the spacecraft will be going to the lunar's 100-kilometer circular orbit, and then the lander, which is about 1,700 kgs, and the rover, which is about 26 kgs. And they are going to work on the lunar surface for a lunar day, which is like 14 Earth day. And we hope that in case they survive the lunar night, then we can have much more lunar days of observations. So where we are landing into the polar regions of the moon. You see in the down the orange colors where we have the primary and alternate landing sites. So this is the region which has not been explored so far by any landing missions. And that's why we are going to see something unique and new. We also are working on a collaborative mission with the JAXA, Japan, on LUPEX, which is basically a lunar polar exploration mission, where the focus is essentially to look at lunar polar water distributions or the other volatiles and elemental composition of the lunar surface. And this would be a mission where India is going to provide the lander and JAXA is going to provide the launcher as well as the rover. This is still in preparation. A lot of discussions are going on with in ISRO and JAXA, and hopefully you will hear something much more concrete on this in the next year or so. So with this, I would like to thank you all for listening patiently, except to tell you that if you are interested to look at any of these data sets, which is there from the Chandrayaan-1 or Chandrayaan-2, you can come to this website, which is accessible for all the public across the world. Thank you very much for listening patiently. Thank you.